The Foundations of Geometry by David Hilbert. Chapter 2. The Compatibility and Mutual Independence of the Axioms. Section 9. Compatibility of the Axioms. The axioms, which we have discussed in the previous chapter and have divided into 5 groups, are not contradictory to one another. That is to say, it is not possible to deduce from these axioms, by any logical process of reasoning, a proposition which is contradictory to any of them. To demonstrate this, it is sufficient to construct a geometry where all of the 5 groups are fulfilled. To this end, let us consider a domain omega, consisting of all of those algebraic numbers, which may be obtained by beginning with the number 1 and applying to it a finite number of times the 4 arithmetical operations: addition, subtraction, multiplication, and division, and the operator the square root of 1 plus omega squared, where omega represents a number arising from the 5 operations already given. Let us regard a pair of numbers xy of the domain omega as defining a point, and the ratio of 3 such numbers u, v, and w of omega, where u, v are both not equal to 0, as defining a straight line. Furthermore, let the existence of the equation ux plus vy plus w equal 0 express the condition that the point xy lies on the line UVW. Then, as one readily sees, axioms 1, 1 through 2, and 3 are fulfilled. The numbers of the domain omega are all real numbers. If now we take into consideration a fact that these numbers may be arranged according to magnitude, we can easily make such necessary conventions concerning our points and straight lines as will also make the axioms of order group 2 hold. In fact, if x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3, and so on, are any points whatever in a straight line, then this may be taken as a sequence on this straight line, providing the numbers x sub 1, x sub 2, x sub 3, and so on, or the numbers y sub 1, y sub 2, y sub 3, and so on, either all increase or decrease in the order of the sequence given here. In order that axiom 2, 5 shall be fulfilled, we have merely to assume that all points corresponding to the values of x and y, which make ux plus vy plus w less than 0 or greater than 0, shall fall respectively upon the one side or upon the other side of the straight line UVW. We can easily convince ourselves that this convention is in accordance with those which precede, and by which the sequence of points on a straight line has already been determined. The laying off of segments and angles follows by the known methods of analytical geometry. A transformation of the form x prime equal to x plus a, y prime equal to y plus b, produces a translation of segments and of angles. Furthermore, if in the accompanying figure we represent the point 0, 0 by O and the point 1, 0 by E, then, corresponding to a rotation of the angle COE about O as a center, any point xy is transformed into another point x prime y prime so related that x prime is equal to a divided by the square root of a squared plus b squared times x minus b divided by the square root of a squared plus b squared times y. And y prime is equal to b divided by the square root of a squared plus b squared times x plus a divided by the square root of a squared plus b squared times y. Since the number the square root of a squared plus b squared is equal to a times the square root of 1 plus the quantity b divided by a squared. Since the number belongs to the domain omega, it follows that, under the conventions which we have made, the axioms of congruence group 4 are fulfilled. and the same is true for the axiom of Archimedes. From these considerations, it follows that every contradiction resulting from our system of axioms must also appear in the arithmetic related to the domain omega. The corresponding considerations for the geometry of space present no difficulties. If in the preceding development we had selected the domain of all real numbers instead of the domain omega, we should have obtained likewise a geometry in which all of the axioms of groups 1 through 5 are valid. For the purpose of our demonstration, however, it was sufficient to take the domain omega containing on an enumerable set of elements. The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Wrenholt. Programming and illustrations by Jim Wrenholt. 2019. Portrait of David Hilbert by Reida Wrenholt. Thank you for listening.